What's up, everyone? In our first video, I just briefly introduced to you what conic sections are and the different types of conics that we're going to be studying. In section 1, we're studying circles as our first conic. And these are the ones that you have a good amount of experience working with because you see a lot of them in your geometry course, right? So hopefully a good amount of this will be just a good brief review for you of what circles are and the properties associated with them. All right, so we know a circle to be a collection of points that are all equidistant from a fixed point called the center, okay? And then that distance that each point has between it and the center, we know that to be the radius of the circle, right? So since this definition involves a distance between 2 points, we can actually use our distance formula to derive the equation for a circle. So I'm first going to do that for a circle that's centered at the origin. Okay, look at the picture here. We've got the center at 0, 0, and we have just this random point with coordinates x, y that's actually on the circle. And then, of course, the distance between those 2 points is labeled as r here. So the standard form of the equation for this circle could simply be thought of as r equals, so your distance equals, the square root of x minus 0 squared plus y minus 0 squared. All right, and of course x minus 0 and y minus 0, those are both really just x and y. So I can think of this as r equals the square root of x squared plus y squared. And then I'm going to square both sides here so that I can drop the radical. And I'll end up with r squared is equal to x squared plus y squared. And right there's your standard form. Typically we write it in reverse here as x squared plus y squared equals r squared. Okay. Now, many of you have taken trigonometry or you're studying it right now. In trig, you work with the unit circle, very important circle for trigonometry. That's a circle centered at the origin whose radius is 1. So if we make r 1 in this equation that we just derived, that means the unit circle has the equation x squared plus y squared equals 1. Hopefully that looks familiar to you. Okay. Now, let's say we want the center of the circle to be somewhere other than at the origin. So let's just say the center is moving to a point of hk, where h is the x-coordinate of the center, k is the y-coordinate. Then you can simply apply a transformation rule, specifically a translation, to your equation, and that turns it into the following: x minus h squared plus y minus k squared is equal to r squared. Okay. All right, so let's write the standard form of the equation of a circle whose radius is 4 and whose center is 2, negative 6. So obviously the 4 is an r value. The center being given to us, 2 is like h. Negative 6 is like k. So substitute those each in to the formula from above. So I'd have x minus 2 raised to the second power plus y minus negative 6 raised to the second power is equal to 4 raised to the second power. And then I'll simplify that just a little bit. X minus 2 raised to the second plus y plus 6 raised to the second is equal to 16. There's your standard form. Okay. Now let's graph an equation that's in standard form. All you need to do is use the equation to identify your center, identify your radius, and then you can plot some points from there, okay? So based off of this equation, I would say that the center has coordinates of +1, -3. Okay, effectively we need to change the sign on each of the values as they appear in the equation when we then list out the coordinates of the center. Okay, so let's plot that. And then your radius is going to equal the square root of the constant. So in this case, it would be 4. Okay. And I can now use that radius to come up with 4 points that will help me define this circle. Okay. So from the center, let's just move 4 units up. From the center, move 4 units right. 4 units down. 4 units left. Okay, so those 4 points are the nice critical points to help you draw this out. It's kind of tricky to do, just kind of do your best here. And there we have it. All right, now suppose we use algebra on the equation of a circle in standard form to remove the parentheses, to clear the parentheses, okay? So in this particular equation, what I mean by that is we're squaring x plus 2, we're squaring y minus 3. So that's going to lead me to x squared plus 4x plus 4 added with y squared minus 6y plus 9 equal to the constant of 9. And then I'm just going to kind of combine like terms and do some rearranging here. So I'll put the 2 squared terms first, then the 2 linear terms, and then I've got some constants, 4 and 9. Those combine to make 13. And then I'm going to subtract the other constant of 9 over to this side. That's going to lead me to plus 4 equals 0. Okay. Now, when your equation is in this form, this is known to be the general form for the equation of the circle. All right. So notice the format here. You have 2 squared terms that are being added together. Right there's my indication that it's a circle. And then you follow that with your 2 linear terms and then your constant. All right. So this is, again, your general form. All right. So what if we are asked to graph an equation that's in this form? Well, it's really challenging to do. In order to graph it, we're actually going to want to put it back into the standard form, and that's going to require completing the square, okay? And we're actually going to have to complete the square 2 times here. So first thing I'm going to do is in order to complete the square, I need my squared terms to both have coefficients of 1. So I'm going to begin by actually dividing the entire equation by 2 here. That's going to lead me to x squared plus y squared minus 6x plus 4y minus 12 is equal to 0. Okay. And then I'm going to do some rearranging. Let me actually move this. Need some more room here. Okay, so now here's going to be the setup. All right, I'm going to group together x squared with negative 6x. So the squared term and the linear term that involve x are coming together. And then I'm going to add on to it a blank, which I'll use to complete the square. All right. Plus, and then I'll do the same thing with y squared and 4y. I'll group those together, plus a blank. And I'm going to equal that to my constant of 12. So notice I'm adding that over to the other side, plus blank, plus blank. All right, and the reason I have to put in the blanks over there is to keep the balance in my equation, right? If I end up adding numbers over on the left-hand side, I've got to do the same on the right-hand side, okay? All right, so use this value right here to complete the square for x, all right? Half of -6 would be -3, and -3 squared would be +9. So I'm going to add 9 into both sides. And then use this number to complete the square for y. Half of 4 is 2, and 2 squared is 4. All right. Now we can factor x minus 3 squared plus y plus 2 squared is equal to 25. And now we're in complete standard form. The center of this circle has coordinates of 3, -2, and the radius equals the square root of 25, which of course is 5. Now we can graph very similar to the last example. All right, so right there's your center. From there, we move 5 units up, down, left, and right to get 4 more points. All right, and just do your best to draw this out. And there we have it.